All right, so today what we're going to be studying is we're going to study this thing called the basic sine and cosine ratios, okay? Now let's focus on the key ideas that we need to study today. First thing that I need you to understand is when we're talking about a right angle triangle, we usually have some form of angle. In this case, we have the angle theta in the corner. We have its opposite, which is the side which is directly across from the angle, and its adjacent side. So when we're talking about the sides, we're talking literally about the legs of the triangle here, okay? The opposite and adjacent are the legs of the triangle, and you already understand what the hypotenuse of the triangle is. The hypotenuse of the triangle is this part here. And what we found was when we were doing our original ratios of triangles at the very beginning of the unit, we were looking for some relationship between larger and smaller triangles. And what these ratios, such as the tangent, the sine, and the cosine do is it actually generates those ratios or the decimals of those ratios so that we can find either sides or we can find lengths. Now, the long form, you've already studied it. You know that tangent is equal to, which was the opposite, which was this, divided by the adjacent, okay? And we use that to find certain angles or sides. Okay, we also have another one that is called the sine of theta, which is the opposite side divided by the hypotenuse. And we'll just write that down. And finally, we have a thing called the cosine, which is equal to the adjacent divided by the hypotenuse. And all we're doing is we're relating the ratio of the sides to a function that relates it to the angle. Now, let's go over the short form, okay? And then we're going to create something that we can remember every time we use this. The short form for tan, you're going to write as O over A. The sine, you're going to write as O over H. For cosine, you're going to write A over H when we're doing our calculations, okay? So, how do we remember this? Well, we literally have a special word that we use to remember it. We say sine, we have S, C, and T. Sine, cos, and tangent ratios. These are the primary trigonometric ratios, okay? Now, we're going to say the following. Sine is O over H, and cos is adjacent over H, and tan is O over A. In mathematics, we relate this to the word so, ka, toa. You'll hear this word all the way from now until when you reach university. We use the word SOHCAHTOA to remind us that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay? Now, let's go on to the problems that we're going to work with for today. Now, just remember before we go on, these things are called the primary trigonometric ratios. Trig, and we'll say ratios. That is what we're saying. So if ever I ask you for the primary trigonometric ratios, what I'm asking you for is sine of theta is equal to some number over another number. That's all I'm looking for. Okay? So now, let's move on to our topic of the day. We have 2 examples to work on for today's lesson. All right, so we need to take a look at this problem here. Each of these problems require us to find some key concepts. We have this thing called a primary trigonometric ratio for the angle that we're looking for, okay, for each triangle. And then we're going to take a moment and we're going to make sure that we express them as the decimals that they are. So here is what we have. And then we're going to find an angle of measurement using one of the angles. Okay, now let us start by taking a look at example 1. Here we go. So example 1, we need to find the example trigonometric ratios for this angle here. So I tend to put like a box around it or highlight it or something. And then I'm going to go and identify all the sides. So now that side there, we're going to call the opposite. And then the side beside the angle is the adjacent. And then, as you know, this last side is the hypotenuse. So here's what we do. We need to use that SOHCAHTOA thing from before. So I always write SOHCAHTOA. Now that will remind me that when I'm trying to find my primary trigonometric ratios, I'm going to always say sine of theta is equal to O over H. Cosine of theta is equal to A over H, based on my words up here. And tan of theta is equal to O over A. So now all we have to do is use the labeled sides that we always do on our triangle to help us find those sides. So when I look at sine of theta, so now I say sine of theta is equal to, well, I look for my opposite. My opposite is 10, so I'm going to write 10 divided by 26. Cosine of theta is going to be 24 over 26. Tan of theta, looking at my thing here, we have tan of theta will be 10 divided by 24. And we're done for our primary trigonometric ratios. Now, looking at each of these ratios, I would be remiss if I didn't tell you, a lot of times math teachers like to have these in lowest terms. It's just good for you when you're doing it. So we take a look at sine theta, and if I look at sine theta, I can take a look at it, and I look at 10 and 26, and both of these could be divided by 2. So we end up with sine of theta is just 5 over 13. And then cos of theta, similarly, we could divide both the top and bottom by 2. And we end up with, well, 12 over 13. And tangent theta is divided both the top and bottom by 2, and you end up with 5 over 13. And that is our lowest form trigonometric ratios for all 3 types of angles using tan, sine, and cos. So now let us go and use what we learned from our previous lesson about finding the angles. You know the following. So in this problem, it asks you to find the angle to the nearest degree. Okay, so here's what we're going to do. Before, when you used to do your tangents, you would take, if I needed to find the angle here, so let's say I need to find the angle. Before, with your tangent, what you would do is you would literally say, for tangent, you'd go theta is equal to tan inverse of 5 over 3. 13, I mean. And what 5 over 13 is just 5 divided by 13. So when you punch that into your calculator, you're going to get a decimal of 21 points, of 23 point something. So that turns out to be 23 degrees. Okay, now that is the angle. Now you will do the same thing for cosine of theta. Make sure you correct that work here. And sine theta. So when we want to find theta using sine theta, we use second function of sine, and then we go 5 divided by 13. So remember, this is the second function of sine on your calculator. Okay? You use that and then punch 5 divided by 13 and then end the bracket. When you calculate that, you are going to get 23 degrees again. And the same can be said for cosine. You end up with cosine, cos inverse of 12 divided by 13 on your calculator, and punch that in, and you end up with theta is equal to 23 degrees. And we're done. Now, what I'm going to ask you to do is I'm going to ask you to take a look at the next problem, and I would ask you to find the primary trigonometric ratios for all three sides. You need to find the following. I need to know sine of theta. What is it equal to? I need cosine of theta. What is it equal to? And I need tan of theta. What is it equal to? And what we'll do is we will, first of all, make sure that you identify the opposite, hypotenuse, and adjacent. So I'm going to pause the video. You label it on your sheet, then I'll show you what the hypotenuse, opposite, and adjacent are. All right, so here we go. Let's take a look at this picture. So here is our side. The side here is the angle that we care about. Here it is. That side is the opposite, so I'm going to label it as the opposite. Remember, the opposite is the angle that is the side that is across from the angle, and then we have the adjacent leg, and then we have the hypotenuse. So now when we calculate sine of theta, we're going to write the following: 4.1 divided by 7.6, because remember, sine of theta is O over H, right? So now let's do the same thing for cosine of theta. Now cosine of theta is A over H. Now let's go and take a look at that on our sheet here. So A over H is 6.4 and H is 7.6. So we have 6.4 divided by 7.6 for our cosine, right? And for tan, remember, keep looking at that SOHCAHTOA thing that we had at the top. Tan is going to be SOHCAHTOA. Tan of theta is equal to O over A. And so tan of theta in this case is going to be 4.1 divided by 6.4. Now pause the video and I want you to calculate the angle theta this time. Okay, so pause the video, go. So for the angle theta, we have theta is equal to basically sine inverse, which is, remember, it's second function and sine and then put your stuff in brackets. And that's going to give you the following answer. Theta is equal to 33 degrees, rounded. We can do the same thing for cosine. So cosine of theta is equal to cosine inverse of 6.4 divided by 7.6, which gives us theta is equal to 33 degrees again when you punch that in your calculator. So remember, cosine inverse is going to be the second function, sine, not sine, but cosine. Second cosine, and then we put our stuff in a bracket. So 6.4 divided by 7.6, and you get 33. And the same thing for tangent. So theta is equal to tan inverse of 4.1 divided by 6.4, which gives us 33 degrees again. And we are done. So that's the end of example 1. Pause the video and copy it down, and then we'll move on to example 2. All right, so for example 2, this is not the real example that I really wanted to do, but I wanted you to understand that when you calculate the sine of an angle, you need to give me these answers to a minimum of 4, I would say 4 decimal places. Now, you use the 4 decimal places because that is the most accurate that you're going to get. So when you type in sine of 0, you're just going to write in sine and then hit the number 0 on your calculator. So click sine and then hit 0. So sine of 0 is just 0. Punch in sine of 35, you're going to get 0.5736. Sine of 45 is 0.7070, no, 71 when you round it properly. And do the same for sine of 72. Punch that into your calculator, check to make sure that you get that. So you get 0.9511. And let's go for the last one, sine of 90. And when we get sine of 90, we're going to get 1. So now we're going to do cosine of 0. Cosine of 0 is 0. Nope, it's not 0. Go back, do it again. Cosine of 0, when you punch that into your calculator, it is 1. Okay? Cosine of 35 is 0.8192. Cosine of 45, 0.7071. Cosine of 72 is going to be 0.3090. And then the cosine of 90 is 0. Now, the only way this works when you're doing these calculations is you need to make sure that your calculator is set to degrees. Always make sure that your calculator is set to degrees. If not, make sure that you reset your calculator. The calculator. And if you reset your calculator, there's usually a button at the back of your calculator, or you have to go into mode, setup, and then hit reset, and then it will reset your calculator. If you have any issues with that, please email me immediately and I will help you fix that. Okay? So now, example 3 is our final example of the day. So this requires us to use all the knowledge we've learned with all 3 different trigonometric ratios. You might have cosine, sine, or tangent, but you have to figure out which one you're going to use. So, for example, 3. Let's read that, and we'll go through it right away. It says, if given any two pieces of information about a triangle with respect to a side and an angle, and from the angle 90, the remaining sides can always be determined and solved. So I could ask you to solve an entire triangle. Okay, so how do we go about doing that? So it's very similar to what you used to do when you had to find all of the sides of a triangle and then tell me what all the angles are. Okay, there's many ways to solve this, right? But I'm not going to go over all the ways. But what we're going to do is we're going to use this information to help us find certain sides. We have an angle and a side, right, of this triangle. So we have the angle, which is 25, right? And this, I'm going to circle. And this means that this side here is the opposite. And then this side here is the adjacent. And then this is the hypotenuse. Now, as you know, with any triangle, we label the opposite sides from the angle, the letters. So this is side A. This B, if that's angle B here, right, that means that this is side B here. And then this side here is side C. So let's go about how we solve this. There's two ways to find the sides of my triangle. Okay? There's two ways to find the sides of your triangle. Okay? So, one, you could use cosine of 25 is equal to, you know that it's going to be from SOHCAHTOA, remember? SOHCAHTOA. That cosine of 25 is going to be the adjacent, which we will call the letter A. And we're going to divide that by the hypotenuse, 25. Or you could have found sine of 25 degrees is equal to, well, the opposite, which is the letter B divided by 25. And then solve accordingly for B to get the side B. So now take a moment, go through the math, see if you can get the answers. So here we go. All right, so for cosine A, so I want to get rid of this A here. So what I'm going to do is I'm going to multiply both sides by 25. So I'm going to get 25 cosine of 25 degrees is equal to the letter A. When I solve for that, you're going to get A is equal to 22.7 meters. And that's what we get for our side A. Now, for side B, I'll do the same thing again. Multiply, get rid of the 25 by multiplying both sides by 25. And you're going to get 25 sine of 25 is equal to B. So now B is equal to 10.6. Now, some of you like to use Pythagoras theorem. That is definitely not a problem. That's how we found our two sides for side A and side B. That's great. Now that I've got that, I would take a moment and write those numbers onto my triangle so I know what's left over. But the last thing to do, we have to find the last thing in our triangle that's missing. If you notice, we are missing angle A. To find angle A, all we have to do is this. To find angle A. So you know that the entire angle of a the interior angles of a triangle are total up to 90. So A is equal to 180 minus the 90-degree angle in the corner minus 25 degrees. And that is going to give you 65 degrees. So angle A is 65. So we have all three things. So I could literally say angle A is 25, angle B. So we would say angle A equals 65. Angle B equals 25. Angle C equals 90 degrees. And then little a is equal to 22.7 meters. Angle B is equal to 10.6 meters. And side C is equal to 25 meters. So if you do not have a picture of what's going on with your triangle, all you have to do is make sure that you take a moment and give me a summary of all the angles and all the sides of the triangle at the end of your problem. And we're done. Now, you could have also done this entire problem using cosine law to find one of the angles, one of the sides, and then go and use Pythagoras theorem to find the missing side. You could have done that as well. But that is how we're going to do this specific problem. So take a moment and copy down all that information for our triangle. Okay? Then what I'd like you to do is listen to the summary at the end of this lesson. Okay, so now there are three primary trigonometric ratios for right triangles. Okay, they're sine, cosine, and tan, right? So we have which is opposite over hypotenuse, cos, which is adjacent over hypotenuse, and tan, which is opposite over adjacent. So take a moment and make sure that you fix this to be opposite over adjacent. I may have made a mistake on the online version of this, so just make sure you turn tan into opposite over hypotenuse. Now remember, this will only work with right angle triangles. If we have a right angle triangle, we can use so, ka, and toa. Next week we will do some practice problems with some new things that don't necessarily have triangles that are right angles. So do these problems. These problems are quick and they may seem like a lot, but they are pretty quick and easy once you get the hang of it. Okay? Good luck, guys.